Welcome to PS2 Activity 5.4, and the lesson is called Energy Transfer and Systems. So our learning target today is we're going to investigate energy systems. And my expectation for you is that you're going to be able to draw an energy transfer diagram. So this is the third time in class we've practiced this. So I expect you to be able to draw an energy transfer diagram for the basketball and racquetball bouncing together. So if you remember, we did a lab where we had the basketball and the racquetball. Well, first we dropped the basketball by itself and then recorded how high it bounces on the first and second bounce. Then we did the racquetball, then we did them together. And what you're gonna do is you're gonna draw an energy transfer diagram for that happening. So when we look at it right here, let me go back to this slide. So we're gonna explain what a system is today, and we will use an energy transfer diagram to describe what happens to the energy when a racquetball and a basketball are bounced together. So here are the procedures. In activity 5.2, you recorded observations of the basketball and racquetball bouncing. Now what you're going to do is draw an energy transfer diagram for the basketball and the racquetball. So on page 57, you have that big square, that big box. Go ahead and pause the video and draw an energy transfer diagram for the basketball and the racquetball. All right, so I'm not going to show you what it's going to look like because I don't want you just to copy it down. But when we go over this activity in class, we'll see how close you are. So this is the third time we've practiced this, so we'll see if you've nailed it so far. Now, excuse me, if you think of the basketball and the racquetball separately, the amount of energy seems to change, increasing for one and decreasing for the other. So if you remember, the basketball bounce height decreased, well, the racquetball bounce height increased. So if you think of both balls together, the amount of energy seems to be the same. However, it is simply transferred from one ball to the other one. So again, if you think of the both balls together, the amount of energy seems to be the same. So the basketball transferred some of its energy to the racquetball. So when you think of things together in this way, the basketball and the racquetball together, this is called a system. If you think of both the basketball and the racquetball together as a system, then the energy in that system is conserved from when one ball hits the other. So again, the basketball, when you had the racquetball sitting on top, the basketball did not bounce as high, and that's because it transferred some of its energy to the racquetball. Now, did the basketball lose some energy? Absolutely. Did the racquetball gain some energy? Yes. Now, if you think of them both together as a system, the system as a whole did not lose any energy. It was conserved. It was just transferred from the basketball to the racquetball. So what I want you to do now is I want you to complete these follow-up questions. And these are on the back side on page 58. You observe that the basketball and the racquetball eventually stopped bouncing. What other objects are in the system with the basketball and the racquetball? So what other things do you think are in the system that work together like this? So think about what we were doing outside. What other things are in the system? And question 2. So now you're going to be working on question 2. So on the activity sheet, 5.4, and you'll see this again on page 58. What I want you to do is identify the following for the basketball and the racquetball and the tennis ball in demonstration. So if I'm reading off the paper, it says a system can be made of one or more objects. Think of the possible systems that can be made of objects involved in a basketball and racquetball demonstration. In which system does the energy decrease? In which system does the energy increase? And in which system does the energy stay the same? So again, think of the possible systems that can be made of objects involved in the basketball and the racquetball demonstration. In which system does the energy decrease? In which system does the energy increase? And in which system does the energy seem to stay the same? So go ahead, pause the video and answer these questions. All right, so now you've had a chance to work on that. Let's look at some of the key points here. Now, if you think of the basketball and the racquetball separately, the amount of energy seems to change because the basketball bounced less. The racquetball bounced more when you put one on top of the other. So increasing for one and then decreasing for the other. Now, if you think of both the basketball and the racquetballs together, the amount of energy seems to be the same. It is simply transferring energy from one ball, the basketball, to the other, the racquetball, or tennis ball if you use the tennis ball. Now, when you think of things together in this way, it's called a system. And if you think of both the basketball and the racquetball together as a system, then the energy in that whole system is conserved. It's not going anywhere. So when one ball hits the other, the total amount of energy is the same within the system. Now, you have learned that some things seem to lose energy while other things seem to gain energy. Anytime an object or a system seems to get more energy, the energy of another object or system must decrease by the same amount of energy that's transferred from one part of a system to another. So when one part in a system loses, another part in the system gains. So what could be the reason that one thing slows down or stops faster than another? So again, what do you think could be the reason one thing slows down or stops faster than another? Again, if you're looking at energy transfer, think about things that might cause the one basketball to slow down faster than the one that didn't have the racquetball on it. And why did the racquetball bounce, 30, 40 centimeters, but then when you put it on top of the basketball, it bounced a lot higher? So what could be the reason one thing slows down or stops faster than another? Again, think of energy transfers. And the last thing I want to do today is I want to add some scientific principles. So energy can be transferred between systems. Energy cannot be created nor destroyed. And if energy appears to be missing, either it has been transformed to another type, in other words, converted from, say, sorry, there was the bell between class periods, but so it could have been converted, say, from GE to KE and back and forth, or it has been transferred to another system, like the basketball might have transferred it to the racquetball, if you consider them to be two separate systems. Or in the pendulum's case, the pendulum slows down because it's transferring its energy to the air, which is a different system, unless you want it to be the whole system. Because you could say the air and everything is the whole system, everything's together, the pendulum, the air. But then, if that's the case, the energy is conserved within the system. So this finishes up activity 5.4. If you have any questions, make sure you ask your teacher, and if you're absent and you're finishing this up, just show the lab to your teacher so that they know that you completed it. Thanks, and again, as always, ask questions if you have them.